The function below has at least one rational zero. Notice the function below is a polynomial in descending order. Use this fact to find all zeros of the function. If we write this very carefully, we know that 7 is actually equal to a sub 3, and then negative 4 is equal to a sub 9. And remember all the possible rational zeros, we'll have the form factors of negative 4, which would be plus or minus 1, plus or minus 2, over and plus or minus 4 over the factors of 7. And what are the factors of 7? 7 is a prime number, so we only have plus or minus 1 and then plus or minus 7. So these are the possible rational zeros. I'm going to bubble this because this isn't actually correct mathematical notation. However, notice we could try to figure out which one is a zero here. Well, let's make an educated guess. Let's try h of 2. So let's evaluate h of 2. 2 is a rational number. And let's see what we get. 7 times 2 cubed plus 9, 2 squared minus 12 times 2, subtract 4. 2 cubed, 2 squared, 12 times 2. Okay, let's simplify this. That's 56 plus, let's say, 36 minus 24 minus 4. I don't think that's 0. That's not 0. So let's try something else. Let's try h of negative 2. Why don't we try h of negative 2? Maybe this will get us somewhere. H of negative 2. I actually, I'm going to move this work. I should have done this work off to the side. I apologize. I'm going to move this really quick. I'm going to move it over here so I could save myself some room. So a lot of times I would do this. I would put my important work aside. What's h of negative 2? Let's find out. 7 times parentheses raised to the third power plus 9 times parentheses raised to the second power minus 12 times parentheses minus 4. And what goes in those parentheses? A negative 2. Let's see what we get here. Now we have negative 56 plus a 36. So that's negative 20 plus a 24. That's positive 4, subtract 4. That is 0. Aha! Now by the factor theorem, we know something. By the factor theorem, we know that x minus a negative 2, which equals x plus 2, is a factor of h of x. All right, we're in business. That allows me to use synthetic division, because notice x plus 2 is monic binomial. A monic binomial is a shortcut. Well, a monic binomial provides a shortcut called synthetic division to do the long division for h of x. We're going to go ahead and divide by x plus 2 using synthetic division. So our 0 is negative 2. And now we'll write the coefficients, 7, 9, negative 12, negative 4. We'll first bring down the 7, and we are going to multiply and add. So this is 7 times negative 2 is negative 14. Add it to 9, we get negative 5. Negative 5 times negative 2 is positive 10. Add it to negative 12, we get negative 2. And negative 2 times negative 2 is positive 4. Add it to negative 4, we get 0. Now, this tells us a lot about h of x. H of x is now equal to the quantity x plus 2 multiply to what? 7x squared minus 5x minus 2. And can we factor this? Let's find out. H of x is equal to x plus 2. Well, 7 is nice. We just have 7 times x, and then we have, let's put a 2 here and a 1 here. Well, I think this is going to do it. Oh yeah, it is. There it is. We have written h of x as a product of 3 linear factors. Let's find the zeros. If we find the zeros, we need the output, or the y value, to be equal to 0. And not a total surprise here. You could write really fast. X plus 2 is equal to 0. 7x plus 2 is equal to 0. X minus 1 is equal to 0. So what are our zeros? The zeros for h of x are negative 2 sevenths, negative 2, and positive 1. That's the final answer. Make sure you show lots of work. You gotta show at least the synthetic division. So show work here. Show evidence that you understand mathematical procedures. You also don't forget to write this 0 here. You need this 0 to connect to these zeros over here. Okay. I mean, what does it mean to find a 0 of a polynomial? Well, you have to have the output to be 0, and then we solve for basically the x-intercepts.